Steve here for SSI. Welcome to the shop. A little while ago, a friend of mine asked me to build him a project to hold his chuck key. Something he could get a grip on and turn without using a handle. Well, the chuck key he was using was real small, and the bar that you grab onto with your fingers was real narrow. So it kind of hurt his fingers, and he's getting older, so I decided to take on the task of building a chuck key holder for him. Well, I'm going to do it for myself with a larger chuck key for my drill press. I've got several of these, so if it doesn't turn out too good, it's not that big a deal. So I've got a standard 1.5 inch diameter piece of aluminum, piece of scrap that I've got, and my idea is to bore a hole in it, insert this chuck key, knurl it, and put in the bar that would normally be the handle. So my plan is to go ahead and use the same bar that came with the chuck key, but I'll go ahead and leave this thumb tang sticking out just in case I want to add more pressure onto the turn instead of just using this. So that's today's project. From the measurement of this piece, this measures 1/2 inch. So I may or may not be able to get it with a 1/2 inch drill bit. I may have to ream it just a little bit larger. I want to try to keep it as tight as I possibly can, just so it doesn't wiggle around too much. I think my next size reamer up is 512 thousandths. And it's 1 inch, 100 thousandths from the bottom of this, or from the top of this pinion up to the top of the actual shaft. So I'm going to go ahead and turn and face, or face and turn, this piece of material down to 1 inch 491 thousandths and make it the same size as I did in the knurling project that I did earlier. So I'll go ahead and do that, bore the hole, and we'll see how this fits. Okay, I've got the hole drilled, everything turned down, 1 inch 492 thousandths, so I missed my 2/10 again, but that's okay. I think it'll work just fine. So here's the test fit of the little drill chuck. There's a little bit of writing or stamping here on the end of this, so I may just go ahead and just sand this down a little bit until it just fits inside of that hole before I would tap it in. Because once I tap it in, I can't turn it or move it or anything to see if I can get it to line up. To see if I can get it to line up with the hole for this shaft to go through it. Because once you miss, you may have to take a pair of pliers or something, and you don't really want to put a pair of pliers on the teeth of this or on the end of this, so I'll probably either just sand or file, which probably sanding would be the best. Just use a real coarse grit to try to knock the edges off these stamp lines or stamp marks there. So what I want to do with this piece is, after I fit this in, I want to be able to use this pin to lock it in place, and I still want to retain this press fit that this pin originally came with. Now the hole in this drill chuck key is 255 thousandths. The closest thing I've got is a letter F, which is 257. Well, I'm going to drill the aluminum on one side of this hole at 250 thousandths, or 1/4 of an inch. And on the other side, I'm going to drill it letter F. So I'll do that in the drill press. Now, one thing I have to get right is the distance from the top of this pinion to the top or to the center of the hole, is 775 thousandths. So I've just got to make sure I hit that mark from the edge of this workpiece back to 775 thousandths for center of the drill bit, so the two holes will line up. Once I get everything dry fit where I want it to go and I make sure that it's okay, then I'm going to come back and I'm going to knurl this outside piece, and I'll probably give a chamfer, large chamfer, to the end of these teeth as far back as I need to at a 45-degree angle. And it should be enough that I'll miss the hole in the back side so everything will stay flat. So here we are at the drill press. I'm going to go ahead and drill this 1/4 of an inch all the way through. Then I'll come back and drill it letter F to one side. Okay, there it is after it's sanded and filed. I did have to file it a little bit, and I had to make sure I cleaned the edges of these holes out on the inside. Get this thing to fit down in there properly. And it is a snug fit for this pin, so everything should stay nice and firm. I have my knurl set up, and I have 2 stops in play. I've got one for this side close to the chuck, and I've got one for this side toward the tailstock, because I don't want to knurl over the hole I just drilled. So I will run it back and forth using the power feed at about 30 threads per inch. From here I can put on my chamfer, and what I'm going to do is I've marked the end of this piece the same size as the pinion on my chuck key. I'm going to run the lathe backwards and chamfer down until I get to that line. Not the most scientific way to do it, but nonetheless it still works. And I'm going to do this at a 45-degree angle with the lathe running in reverse. The last thing to do would be to part this off, go ahead and do a radius on the back side so it has that nice ball shape on the back of it, and assemble it and give it a try and see if it's what I want. I'm getting ready to part this piece off right here. I wanted to show you a little something, may help, because I know that parting off with a small lathe is a very difficult process, and it has a lot of issues that come with it. So I'm going to give a few little hints. Maybe it'll help you, I don't know, but it helped me. So I'm using a standard high-speed steel part-off tool. Of course, it's adjustable in height and length and all that kind of stuff. So where do we set everything? Well, what I normally do is after I get the part in the machine, I get the tool as close to the part without hitting it as I can. I give myself about an 1/8 inch clearance between the tool holder and the part itself. So I've got that set. The next thing I would do is I put in the tool bit, and what I want to achieve here is to make sure that the tool bit will cut over center. You don't want it sticking way out here because you lose rigidity that way. And that's the biggest issue with parting off on a small machine, is rigidity. You've got enough problems with the compound and the cross slide as it is, not being very rigid. So I'm going to give myself just a little bit of over center length, so I know I can get all the way through the material. Next is the height of the tool. You want it on center or just a little tiny bit below, if at all any, but on center is always the best. Now with Atlas lathes, of course having flat ways, height of center on my 12-inch is 6 inches. It makes it nice when I use this style of scale that's got the stop on the end of it here. I can set tool height with it pretty easily. So I make sure the way is clean. There's nothing underneath my scale. And I try to get it to stand up as straight as possible. And I just want to feel the center height. This is just a little high. And I try to hold it and swing it across the center section there, and I'm just missing it. So I'll pick it up a little, tighten the ways back down. Anytime you use one of these style of tool holders or tool posts that have the dovetail ways and the lock, anytime you make an adjustment on the tool height, you have to tighten this back up to actually get the measurement properly. Because if you set it with this handle in the unlock position, get the height set, whenever you tighten it up, the tool picks up and goes straight ahead, just a few thousandths of an inch depending on the tool maker, and it will throw your measurement off. So this is still just a smidgen high. I just feel it on the way by. So now I can part my piece off. I've already got a line set up of where I want to part. Lock my carriage in place. So I've got my lubricant, which is WD-40, and the nice thing about a variable speed machine is I can speed up a little bit as I go through the part in real time. I don't have to stop, change gears, change belts, anything of that nature, which makes this job for me a little bit simpler. So I'm going to start off at a slower RPM. About 235 it looks like. And start on my cut. as we cut through this, we have to try to give it a little bit of lubricant or it'll start to stick and chatter. Just like so. It can be done on a smaller machine like this, but I have a few advantages that a lot of people don't have. I have variable speed, which is nice, and a nice 4-jaw scrolling chuck, which really helps to hold the work very sure and very steady. Here I am with the radius fixture on the machine. Everything's mounted up, ready to go. I've already set the distance that I need to do the radius. I put a piece of shim stock around the workpiece itself to help shield it from chuck marks. Okay, everything's radiused. I went ahead and sanded it while I had it running. So far there's the finished product. So here's all the pieces and parts. We have our new handle that we just got through making, the chuck key with its handle, and I've taken and shortened it so it's not much longer than this piece itself, so I can also leave the thumb tang sticking out to use it as extra leverage. Now before I assemble this, I want to talk about one thing real quick. One side of this chuck key is chamfered, so it's the handle will find its way in fairly easy. The other side is not chamfered, so it'd be harder to line up whenever this goes together. So this is the side that I'm going to press in, or probably tap in lightly with a hammer. And this is my chamfered side, so I'm going to have it toward my press side. And I want to make sure that that tang is facing the proper direction. Then I'll go ahead and take it to the press it in, then I'll meet you back at the drill and we'll see how it works. Alright, here we are back at the drill press. This is the original chuck key right here. Works just like any old chuck key. Here is the new and improved model. I did have one issue. Whenever I pressed this thing together, I broke one of these, or bent it. Bent it to the point I don't want to use it. So luckily I had an extra one, so this one can go in the trash. So how well does it work? Well, I've got a piece of aluminum in the drill here, or in the vise. I've got a 1/2 inch diameter drill bit. I'd say it does pretty well. But what I really liked is if I want to use my centering scope, I don't have to grab onto the spindle and turn it with my hands. I can just put this in here, turn this to wherever I want it to go, and just put a light pressure on it. That's really what I was looking for. So it has multiple applications, but I do really like it for this one. Only thing that I might do if I do this again, next time I might drill a hole through it for a tether. Now the one I made for my friend, I did. I drilled a hole in the backside so he could put a piece of string or leather or whatever around it, because it was for a small chuck. It wasn't for a 1/2 inch chuck like this one. So you can definitely get quite a bit of pressure with that to hang on to a drill bit. And that scrap piece of material, that's what I drilled, what was left of it. So it drilled all the way through that and didn't stop. When the drill tried to stall a little bit, it went ahead and it never did slip. So I think it's good. I think it'll work just fine. So until next time, I hope you enjoyed the show. I hope you maybe possibly got some use out of this little project. And if you like what you've seen so far, please subscribe to my channel. You can always follow the link there to Facebook. Check out my other projects that I've done in the past. There'll be more of these projects to come. And for all you guys that are waiting for a radius fixture video, it's coming soon. I'll do a step-by-step on the radius fixture that I used in this episode. Thanks for watching.